Okay, before we get into the packet, I want to briefly go over what we need to know about greater than, less than inequalities at this point. Okay, solve the inequality, represent with a graph, write the solution above the graph. So first off, make your number line right there, 0. Now here's my x, it's multiplied as a negative multiplier, means eventually I'll be dividing both sides by a negative, so that sign switches. First we got to get that minus 4 to a 0 by plussing 4. Okay, that's going to be negative 12, that's going to be negative 2x. Now it's dividing time, so it means I come down here. Divide both sides by negative 2. So we have x, sign flips, and we have 6. Okay, so 6 is my value. I will not be filling that in, and my question is, does it eat the x? Doesn't look like it. Doesn't eat the x, so it goes this way. That's the only one I have. Now up above, I want you to put, that goes less than, so it's x less than 6, right there. That's where we're putting it above. Okay, my next one, I make my number line. And then I need to apply the distributive property first before I understand what I'm going to do with my sign. So it's going to be 15f plus 9. All right, now you have variables, the letters on both sides, 15f, but they're the same, okay? So I can just get rid of them, and that means the number line can go as well. I don't need that. Now, usually I pay attention to if that eats a bigger number. If it eats a bigger number, it's any solution. If it eats the wrong number, not the bigger number, it's no solution. But I don't have a bigger number, so I check for that line underneath there. There is no line. Okay, 9 greater than 9. That is no solution. Okay, now those two were single symbol problems, single inequalities. Now you have two symbols in the problem, makes it a compound inequality. So I make the number line. So I make the little table, and on one side I put negative 1 less than or equal to x minus 3. I break up the compound into two single inequalities. Then I do a circle overlap and I put x minus 3 less than or equal to 2. Now I'm going to slap a 1 in front of the x, and my x is multiplied by a positive in both places, so that neither sign will change. Okay, now I get the minus 3 to a 0 by adding 3. Line that up, and that's 2, then 1x. You can divide by 1 or just get rid of it. You have x here, you have 2. So I plot 2 on the number line, circle, fill it in. Does it eat the x? Sure it does. Okay, so it goes that way. Now, here I plus 3, and I have 5, 1x. You can divide by 1 or just take the 1 off, and we have x and 5. So extend that a little further. So we got 5, circle, fill it. Does it eat the x? No, it does not. It doesn't eat it, so it goes this way. So they basically collide. Now, up above, you write x down just one time. When they collide, write it down once. You put 2 on this side, 5 on this side. So between x and 5, it has to eat the 5 with an equals to line because it's filled in. Now, here it has to eat the x with an equals to line, fill it in, we're good. That's it. Okay, my next problem. Again, it's a compound inequality. You have two symbols, but it's not the overlap, okay? On one side, I put 2x less than or equal to negative 4. On the other side, 7x greater than or equal to 49. So here x is multiplied by a positive. The sign will not flip. And I don't have to add or subtract anything, okay? I can go straight to my division by 2. I have x here, negative 4 divided by 2 is negative 2. So negative 2 is plotted. Does it eat the x? No, it does not. So it doesn't eat the x, goes this way. Straight to division by 7. and the sign will not change there either because the x multiplier was a positive, okay? So I have x and then 7, so now 7 is my other critical number. Does it eat the x? Sure it does. It eats the x, so it goes this way. Now they spread out. When they spread out, you put x, x, you put 7, then -2, just like that. So it has to eat the x with the line. Here it eats the -2 with the line, okay? And usually you put or in between it. I will not be docking points for that, okay? So that's where you should be at that point. Now, the next part is a little bit new, okay? I'm going to take my number line because it helps illustrate what you're doing. Absolute value is a distance on a number line from 0. When you measure distance, you don't tell somebody it's a negative. I'm traveling from -5 to 0, and I count 1, 2, 3, 4, 5. Just put 5. Now, 4 to 0. What's the distance from 4 to 0? I know I'm going this way, but I don't count my negatives. 1, 2, 3, 4. Okay? So 5 and 4 are the answers. Now, I want you to evaluate these right here, because that is the first part of your assignment. So, first off, you have to simplify the absolute values, okay? Inside of this absolute value, we have -4. Now, go from -4 to 0. Just count. It's that easy, okay? So from -4 to 0, that's 1, 2, 3, 4. Just put a 4 down, then a plus sign. Now from 8 to 0, 1, 2, 3, 4, 5, 6, 7, 8. So that becomes 8. And now I do 4 plus 8. That's 12. Okay, next one. -7 minus 2. Well, this absolute value, first I take -7 minus 2, and that's -9. And then from -9 to 0, I count how many places. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 9. Then I put the minus sign. And then -13 plus 3. That is going to be -10. And then what's the distance from -10 to 0? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So it ends up as 9 minus 10, which is equal to -1. Okay? You can get a negative answer at the end, okay? That's fine. But when I count on the number line, I don't count by negatives. Ever. Okay? All right. Negative inside this absolute value, I have -4 plus 6. So that is -4 plus 10 is 6. And the absolute value is 6. To get from 6 to 0, you have to count 1 mile, 2 mile, 3 mile, 4 mile, 5 miles, 6 miles. Okay? Think of it as counting miles. And then from -12 to 0, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that becomes 12. And 6 plus 12 equals 18. Okay, and that's all we have there. Now, the next part of the assignment, the second and final part, you're solving equations that include absolute values. The variable is inside of an absolute value, okay? It says the absolute value of x equals 10. I have to find the possible values for x. You're not doing a number line because you don't see the greater than symbol or the less than symbol. So what your best bet is to do so you don't get confused is to make this table with two separate equations. Whatever's inside of the absolute value, in this case it's just an x you put on both of them. Now, the next thing you do is kind of make a little dotted line on that side. Do you have anything outside on this side? That doesn't count. I'm over here. I don't have anything outside. I don't have anything in front. I don't have anything behind. Okay? Now, here's my question. There are two places on this number line that you can be 10 slots from 0. Okay? 10 from 0. You can be at positive 10, so put that right there. Or you can be over at negative 10 and you're still 10 places from 0. Those are my answers. You have x by itself in both of them. Bam. Okay. Now the next thing, equals equals. Now write the expression inside. This time it's not just x, it's x plus 12. Again, here, you set whatever's in there on both sides. Now, first make your dash line. Do you have anything in front? Nope. Do you have anything coming behind it? Nope. So you can go fill this out. The absolute value is equal to 2. There are two possible places to be 2 units from 0. Here, I'll even put from 0. You could be at 2. That's kind of obvious. But you can also be at -2 and you're 2 units from 0. Okay? Now, you're going to have to do some operating here, unlike here. Put the 1 in front, get the 12 to a 0. So 1x equals -10. You can divide by 1 or just take it away. That's one possible value for x. Because -10 plus 12 is 2, but the absolute value of 2 is 2. Okay, next. -12 - 12, that would be -14. You can take the 1 out, and x is -14. Both those are your possible values for x, okay? Because you see, if I put -14 and substitute that for x, -14 plus 12 is -2. But the absolute value of -2 is 1, 2. Okay? Next up. This time we have f. Who cares? Just set the expression inside on each side. Now, make your little wall. You don't have anything in front. You don't have anything behind it. So now you measure the two places. You could be 4 from 0. You could be at 4, or you could be over at -4. Those are your two distinct possibilities. Okay? Then 1, 1, and then go to town. +6 + 6, 1f equals 10. You can divide by 1 or just take it away. So 10. 10 minus 6 is 4, and 4 is 4 units from 0. Here, +6 + 6, -4 plus 6 is 2. You can divide by 1 or just take the 1 away, okay? Now, 2 minus 6, if I substituted 2, 2 minus 6 is -4, but the -4, how far is -4 from 0? 1, 2, 3, 4, okay? So if I substitute that in, I would be at +4, but it's 4 from 0, okay? If I substitute 2 in, I'm at 2 minus 6 is -4, but that's 4 from 0. Okay, next one. Inside the absolute value, we have the expression 3x. Dash line. You don't have anything in front, you don't have anything behind it, so now you can label this from 0. So there's two places you can be 12 from 0. You can be at 12, or you can be over at -12. So I would just, here I'd go straight to division. 3 times x, so divide by 3. X would be 4 here, divide by 3, and x would be -4 here, okay? Because you see 3 times 4 would be 12, but 12 is 12 units from 0. 3 times -4 is -12, but -12 is also 12 units from 0. Okay? Now, a little game changer on the next one. Inside the absolute value, you have -3x. So you put -3x, -3x. Now I'm going to put that wall up right there. Now, you have a little problem, okay? Don't label from 0 because you have something outside. You don't have anything in front, but you have something behind, a -2. If you have a plus or minus behind, label that K. And undo the K, do the opposite of -2, which is +2. Now rewrite it. You're at 6, and now you still have the absolute value of -3x. Now I make my wall, and now I don't have anything behind or anything in front, so I can label my from 0. So 6 from 0. So you can be at 6 or negative 6. So divide by negative 3, and x equals negative 2. Divide by negative 3, and negative 6 divided by negative 3 is positive 2. Bam. Okay? Next up, table goes up. So set the expression inside 2x plus 4, 2x plus 4. Now, see that 5? Don't do the rainbows. That is not a parentheses, that is an absolute value. Okay? Don't do the rainbows. What do you do about the 5? You can make a wall, but you're not 35 from 0 because you have this number outside. Now it's in front of the absolute value. We label that with an A, okay? A values I divide by to get rid of them. So I divide by 5 out. Now divide the 35 by 5, and that's 7. So you have the absolute value 2x plus 4. Now, nothing behind it, nothing in front. Now you can put from 0. Trying to figure out how far from, again, to be 7 from 0, I could be at 7 as one possibility and negative 7 for the other. So minus 4, that's 3. Divide by 2, 3 divided by 2 is 1.5. You can get a decimal. Minus 4, 2x equals negative 11. Then divide by 2. Negative 11 divided by 2 is negative 5.5. Okay, next up, keep it going. Keep on your game. So inside, follow the plan. So you got 5x minus 2 on one side and 5x minus 2 on the other. But you can't do the from 0 because I have a number after and I have a number in front. So I got a k value and I've got an a value. Now which one do you get rid of first? Get rid of your k first. So plus 3, plus 3. You have 24, and then you have 6, absolute value 5x minus 2. A value's still there. Don't do the rainbows. So a values we divide, because it's like 6 times, because there's no sign, so that means multiplication. The opposite of multiply is to divide. So that's 4, and now I just have the absolute value of 5x minus 2. Now I don't have any k values, no a values, you're good. So it's 4 from 0. So you could be at 4, or you can be at negative 4, to be 4 from 0. So I plus 2, that's 6. So 5 times x is 6. Divide 6 by 5, and 6 divided by 5, I believe, is 1.2. Now I plus 2, that's negative 2. Divide by 5, and negative 2 divided by 5 is negative 0.4. Okay, next one. The inside expression is x plus 1. Now, you got an a value. A values we divide by. Divide by negative 4, divide by negative 4. Okay, and that's going to be negative 4, and I have the absolute value x plus 1. Now I don't have any more a or k values. But here's the deal. From 0. After you're done with a values, done with k values, that's label that from 0. You cannot be a negative distance from 0. It is impossible. You do not measure distance by negatives. If you end up from 0 with a negative, you write ns, okay? So that from 0, okay, we go with that. Okay, let's keep it together here. Inside of the absolute value, we have the expression x plus 2. Put that on both sides. Got a k value, it's got to go. Minus 4, minus 4. We add or subtract k values. Inverse operations. Okay, And now I'm good. I don't have any k values, no a values, so I'm good. You can label that from 0, and to be 3 units from 0, you could be at positive 3 or negative 3. So that's 1. You can put the 1 there, whatever. Minus 2, if you want to put the 1 because it makes you feel warm and fuzzy, great. Okay, next up. Inside expression is just the x. Well, that ought to be easy, okay? Got an a value, that's got to go. You cannot write from 0 unless if you have an a or a k. You're like, well, what about the h? Don't worry about h when you're solving equations. H values are inside. I take care of those over here. Okay, and I have the absolute value of x. Now, I don't have any a's, don't have any k's. I put from 0, and you could be at 7 or negative 7, and it's solved right there. Inside, x minus 3. We have an a value. A values we divide because they are multipliers, but don't distribute. No rainbows. That's for parentheses, not absolute values. So I have 5, absolute value x minus 3. Now, no more k values, no a values. You can put from 0. So to be 5 from 0, you could be at 5 or negative 5. Plus 3, I get 8. Plus 3, I get negative 2. Bam, bam, good. Last problem, okay? Actually, I want to do a little thing. I want you to make that 3 a negative, because I said so. Why? Because I said so. Inside, you got x plus 2. That's the inside expression. Now, be on the lookout for k values there and a values there. So you got a k and an a. The k goes first. Takes us to 9 now. Negative 3, absolute value x plus 2. Now you still got your a value. Always divide by a values. Negative 3. From 0, you cannot be negative distance from 0 ever, okay? So, no solution. Bam. Let me know if you need help. By the way, don't overthink these. You don't make tables. That's 3 plus 5. That's 3. That's negative 5. It ends up being 3 minus just 5, okay? 4, okay? We know that negative 3 plus 7 is 4. Absolute value of 4 is 4. Plus, and the absolute value of negative 8 is 8. It's 4 plus 8, okay? You can figure out the last one.